Hello friends, welcome back in the today's thermodynamic lecture, that is in the next module of the thermodynamics. So in the last module we have seen the first law of thermodynamics, and it can be stated differently in the it can be stated in three different ways. Firstly, the first law of thermodynamics is simply the law of conservation of energy. That means energy can neither be created nor be destroyed, just it can be converted from one form to another form. And this is the first statement of first law of thermodynamics. Secondly, we have seen the energy of the universe remains constant. The second statement of first law of thermodynamics is the energy of the universe remains constant. And the third statement of the first law of thermodynamics is the total internal energy of the universe, it remains constant, or the total internal energy of an isolated system, it remains constant. These are the three statements of first law of thermodynamics. That means energy can neither be created nor be destroyed, it just can be converted from one form to another form. Secondly, the total internal energy of the universe remains constant, and the third one is the total internal energy of an isolated system remains constant. An isolated system is the system which cannot exchange energy and matter with the surrounding. And from the first law of thermodynamics, we can written as the delta U, which is equal to Q plus W. This is the mathematical statement of the first law of thermodynamics. That is the change in internal energy, which is equal to the heat absorbed by the system, and at that time the work is done on the system. This is the mathematical statement of the first law of thermodynamics. Means the energy will be changed, or the internal energy of an system is changes if either work is done on the system, at that time always the heat is absorbed, and if the work is done on the system, then it is called as a compression type of work. If the work is done on the system, then the compression takes place, and it is called as a compression type of work. And at that time, the some amount of heat, it can be absorbed. Also, the energy change when the work is done by the system. म्हणजे energy ही change होते जेव्हा वर्क हे सिस्टीम वरती होतं किंवा सिस्टीम कडून केलं जातं. And when the work is done by the system, then at that time the some amount of heat is released. The some amount of heat is released. That means it can be expressed by using, that means delta U, which is equal to change in energy U2 minus U1. Delta U means what? U2 minus U1. Means when the U1 is absorbed some amount Then at that time when there is internal energy U1, when it absorbs some heat, and at that time work is done on the system, and it is called as a compression type of work. And also if work is done by the system, at that time the release of heat takes place, and it is equal to minus Q minus W. If heat is released by the system, at that time work is done by the system, and from the sign convention the release of heat is denoted by letter minus Q, and the minus W means the work is done by the system on the surrounding, and therefore it is called as a expansion type of work. It is called as a expansion type of work. In both the cases the energy will be changed. Means if internal energy it absorbs heat, and at that time work is done on the system, that is, this is the change in energy. Also again, if internal energy is U1, if work is done by the system, that means minus W, at that time heat is released by the system, and therefore this is the two type of change when the energy absorbs some heat, at that time work is done on the system, when the system releases some amount of heat, at that time work is done by the system, and therefore the change in internal energy, which is equal to U2 minus U1, which is equal to U2 minus U1. Therefore the delta U, which is equal to Q plus W. This is the statement or the expression or the mathematical statement of the first law of thermodynamics. Then next we have seen some sign convention of delta U. But the value or the sign convention of delta U, which depends on the sign convention of Q and the sign convention of W, as we see. If U2 is greater than U1, and therefore the change in internal energy having the positive value. If U2 means the final internal energy is greater than the initial internal energy, then the change in internal energy, which is equal to positive. And if U2 is less than U1, at that time the change in internal energy having the negative value. The change in internal energy having the negative value. But the values of delta U, it depends on the Q and W. If heat is absorbed by the system, then the value of Q, that is the heat, is positive, and if heat is released by the system, then the value of Q is negative. Also, we have a sign convention of work done in terms of compression and the expansion. If the value of W is positive, means the work is done on the system. That means the compression type of work takes place. Here the compression type of work takes place, and for the compression the value of W is positive. And if work is done by the system on the surrounding, at that time the value of W, or the sign convention of W, is negative, and at that time here if the work is done by the system on the surrounding, and therefore it is a expansion. It is a expansion type of a work takes place. So dear students, all these terms they are discussed in the last lecture. This is just revision of the first law of thermodynamics. Then next we have seen also the first law of thermodynamics in various processes, and we know there are 4 types of processes. The first one is isothermal process. The first one is isothermal process. Isothermal process is a process in which the temperature of the system remains constant. That means the delta T, which is equal to 0, and if delta T equal to 0, at that time delta U, which is also equal to 0. Remember that when the delta T is equal to 0 for isothermal process, at that time delta U, which is equal to also 0. And therefore the first law of thermodynamics in isothermal process is equal to delta U, which is equal to Q plus W. Delta U, which is equal to Q plus W. But for isothermal process, the value of delta U, which is equal to 0, which is equal to Q plus W, and therefore for isothermal process we can write Q, which is equal to minus W, or W, which is equal to minus Q. Remember all these for the MCQs in the CET. म्हणजे CET ला काही MCQs विचारले जातील. What is the statement of the first law of thermodynamics in isothermal process? आणि मग त्यावेळेस आपल्याला सांगावं लागेल W, which is equal to minus Q, or Q, which is equal to minus W for the isothermal process in which the delta T remains constant. So second, we have seen the second type of process is the isobaric process. Second type of a process is the isobaric process. Isobaric process is a process in which the pressure of the system remains constant. And if the pressure remains constant, then that time the change in pressure, which is equal to 0. That means before and after the reaction, the pressure remains constant. That means the change in pressure, which is equal to 0 for the isobaric process. So here we have a mathematical statement of the first law of thermodynamics as delta U, which is equal to Q plus W. Delta U, which is equal to Q plus W. So here we have the work done for the irreversible process as Q in terms of the change in pressure. The work done is having the formula minus P delta V, as we seen W, which is equal to minus P delta V. This is the work done for the isothermal irreversible process. W, which is equal to minus P delta V, and therefore it is equal to Q minus P delta V. But for the isobaric process, the change in pressure remains constant, but here only pressure is the term, and therefore for the isobaric process, remember that for the isobaric process, remember that the change in internal energy, which is equal to Q, but QP. Here it is abbreviated as QP minus P delta V, or here we can write QP which is equal to delta U plus. आपण काय लिहिणार आहे? QP means the heat of the system at constant pressure, or it is called as the heat content of the system at constant pressure, which is equal to delta U plus P delta V. So dear student, remember this formula of the first law of thermodynamics for the isobaric pressure. Means this is the heat content of the system at constant pressure QP, which is equal to delta U plus P delta V. QP which is equal to delta U plus P delta V. हे जे एक्सप्रेशन आहे ते आपण इथे थोडंसं लिहून ठेवूया. QP which is equal to delta U plus P delta V. This is the first law of thermodynamics for the isobaric process. Isobaric process साठी हा first law of thermodynamics, and we have to remember that for the isobaric process the heat content at constant pressure, which is equal to change in internal energy and the pressure volume type of work. So next we have seen the isobaric process. नंतर आपण कुठली प्रोसेस बघितली होती? isobaric process. In isobaric process is the process the change in volume remains constant. Isobaric process is the process in which the change in volume remains constant, and therefore we have the expression of first law of thermodynamics as delta U, which is equal to Q plus W. Here we can write W as a minus P delta V as we seen from this formula. But here the change in volume remains constant for the isobaric process, and therefore delta V becomes 0. So these all terms become 0, and therefore the change in internal energy, which is equal to Q but at constant V, which is equal to delta U, which is equal to heat content, that is Q means the heat content of the system at constant V, means for the isobaric process the first law is written as delta U, which is equal to QV. As we know, up to this lecture we have studied the three types of state functions. What is mean by state function? Properties of a system whose value depends only on the current state of that system. That means which depends only on the initial state and final state of the system, and not on the path followed by that system. And that properties are called as a state function. So we have seen the pressure, volume, temperature, and now the internal energy. All these are the state functions. Means the value of these property depends only on the initial state and the final state of the system. And also here we have to add this delta U, means the change in internal energy, means the internal energy is the state functions, and therefore the heat at constant volume and also heat at constant pressure. All these two, they are also a state function, because delta U is a state function and delta U which is equal to QV, that is the heat content of the system at constant volume, and therefore QV is a state function. Here also delta U which is equal to QP, and therefore the QP and QV are the state functions. But remember one thing, that dear student, Q is not a state function, only Q, that is the heat content, is not a state function, it is a path function. It is a path function. But QP and QV, both these are the state functions. Both these are the state functions. लक्षात राहील सगळ्यांच्या. फक्त Q म्हणजेच heat, it is not a state function, but QP and QV are the state functions, because QV which is equal to change in internal energy, that means U2 minus U1, and it is a state function. Therefore QV is a state function and also QP is a state function, because it is equal to change in internal energy and also the pressure volume type of work. Because we know that the heat and work, both these are the path functions, and pressure, volume, temperature, and now internal energy, and the heat content of the system at constant volume and heat content of the system at constant pressure, all these are the state functions. Means their values depends on the initial and the final state of the system and does not depends on the how they are reached that final state. Means does not depends on the path followed by that system. This is the first law for the isobaric process. So next we have seen the first law for the adiabatic process. The last one is adiabatic process. Adiabatic process is a process in which there is no exchange of heat. Remember student, there is no exchange of heat between system and surrounding, and therefore the Q which is equal to 0. For adiabatic process, there is no exchange of heat between system and surrounding, and therefore the Q which is equal to 0. And therefore the first law of thermodynamics, that means delta U which is equal to Q plus W, it becomes for adiabatic process Q which is equal to 0, and therefore delta U which is equal to W. Delta U which is equal to W. Or in adiabatic process, the heat content of the system is 0. That means there is no exchange of heat between system and surrounding, and therefore Q is equal to 0. Put this value in this first law of thermodynamics. Therefore the delta U which is equal to W, or W which is equal to delta U for adiabatic process. So up to now we have seen the statement of the first law of thermodynamics. It can be stated in 3 different ways. Then next, the expression of the first law of thermodynamics, delta U which is equal to Q plus W, and next we have seen the first law of thermodynamics is first one in isothermal process, the second one in isobaric process, the third one is in isobaric process, and the last one is in a adiabatic process. So up to here we have to see in the last lecture. This is just revision for your consideration. So next we will start with the next term in the thermodynamics, and it is called as enthalpy. आता आपण थर्मोडायनामिक्स मधली नेक्स्ट पुढची टर्म बघणार आहे आणि मग त्याचं नाव आहे enthalpy. Enthalpy is basically means the total heat content of the system. Enthalpy is basically means the total heat content of the system, and it can be defined as the sum of internal energy of the system and the pressure volume type of work. The enthalpy is the total heat content of the system, and it can be defined as the internal energy or the summation of internal energy of the system and the energy arises due to the pressure and volume. Therefore, the enthalpy is denoted by a letter H. Enthalpy is denoted by a letter H, or it is abbreviated as H, and from the definition it is defined as the H means the enthalpy is the sum of internal energy of the system and the energy arises due to the pressure volume. How it can be defined as H, which is equal to U plus PV. This is the expression of enthalpy. This is the expression of enthalpy. Enthalpy is denoted by a letter H, and it is the sum of internal energy U of the system and the energy arises due to its pressure and volume, and therefore H is equal to U plus PV. Next, enthalpy means the H is a state function. Enthalpy means H is a state function. What is mean by state function? Any properties of a system. As we know, what is mean by a state function? Any properties of a system whose value depends only on the initial state and the final state of the system, and therefore enthalpy is a state function. And this is the next function. So here we have seen what are the state functions: pressure, volume, temperature, internal energy, QP, QV, and here one add, that is the enthalpy. Enthalpy is a state function, means the value of these property of the system depends only on the initial and final state of the system. So next property of enthalpy is, this is the first property of enthalpy, is enthalpy is a state function. Next, enthalpy is a extensive property. Enthalpy is an extensive property. What extensive property. The properties of a system whose value or whose magnitude is depend on the amount of matter present in it is called as an extensive property. And enthalpy is extensive property, means its value depends on the amount of matter present in it. And therefore these are the two properties of enthalpy. That means H. Enthalpy is a state function, means enthalpy is depends only on the initial and final state of the system, and therefore we can write the change in enthalpy. That means the delta H, which is equal to H2 minus H1. Change in enthalpy, which is equal to H2 minus H1, as the enthalpy is a state function, and therefore the change in enthalpy, which is equal to H2 minus H1. Also, the enthalpy is an extensive property. Enthalpy is an extensive property. When we see the properties of a system as extensive property and intensive property, in that in extensive property, or the example of extensive property is mass, volume and enthalpy. तिथे आपण बघितलं होतं enthalpy ही extensive property आहे. कशी म्हणजे the magnitude or the matter or the value of these enthalpy, which depends on the amount of matter present in it, means the enthalpy depends on U and PV. And this is the definition of enthalpy. So up to this we have seen we have to introduce the new thermodynamic term, that is the enthalpy. Enthalpy is the sum of internal energy. Enthalpy is the sum of